I woke up this morning to find an inch and a half of snow, which I wasn't expecting at the end of last day of March. So once again, I can't really do much organ wise, so we'll do another CB. This time it's one of my stock ones. If you remember when we did the Murphy DS602 the other day, I've not sent that back yet. If you remember, there was a hum coming over the audio, and we found that changing the SWR changed that hum. So we tested it with another of our sets, and it was exactly the same. But it was pointed out to me we've previously done a DS602 which didn't hum. So I ordered a replacement bass aerial. It's an Antron 99 type thing, Solarcon variant, and we did have a bit of wind damage to the one we were using, but it hadn't affected the range. So we'd kept it as it was. Anyway, I popped that off today. New ones arrived yesterday, and we'll get that up. I did chop the plug off, check the coax, that's absolutely fine. So I soldered the plug back on 6 inches shorter. So it'll be exactly the same, but it'll be interesting to see if the SWR is different from the 1.7 that it was the other day. So, we did a test on the PNI set we did the service work to yesterday, the one we couldn't find the deviation control on, and we had to abort the test. So whether or not that was the aerial malfunctioning or whether it was atmospheric conditions, we'll redo that today when we have replaced this aerial back on its mast. So in the meantime, we'll do this Harvard Bad Buddy. And this looks in nice condition. We've got another one of these on the shelf which has got a couple of knobs missing. And for once, this hasn't got a rusty back. This is some of the thinnest metal you ever see on a CB radio. And it's vinyl coated steel and they're very prone to rusting. But here we go. I'm moaning and groaning, and these are 40 years old, aren't they? These, when they were done, when the clearance happened in like 83, I saw these as cheap as £18. But in fact they were a $49.99 set. I don't like the way they're self-tappers. They're supposed to be oh, these aren't self-tappers. Well, I've always seen self-tappers. Are these the right kind of screws then? Oh, right. Well, I'll take my words back. So they're the same chassis as the Alba CBM5 and the Harvard H404. One of the stumbling blocks with these is the mic. So I've got a standard mic here, and I have rewired it because it's unique. So basically it's Uniden with the transmit and receive the other way round. If you had a Uniden mic, this started life as a Uniden mic, I just simply altered over the transmit and receive wires. So if we look at the chart, Harvard Good Buddy is base 8. Hopefully that's in focus there on top of this radio. So it's transmit, receive, audio and common. And if we look at Uniden, I'm wrong, aren't I? Because Uniden is 2, and Harvard Bad Buddy is 8. So it's not transmit and receive that turn round, it's actually audio and braid. So I've done it wrongly. Okay, well I'll pause the video and do it right. I'll tell you what, we'll power the video. We'll power the radio up first, I think. They are a poorly made set, and they are not reliable. So you just have to hope that they haven't been messed with too much. Very variable Harvard stuff. When you consider the base stations, which use the Cybernet chassis, like is also used in the Amstrads, and when you consider the Harvard 420M with the Cybernet 134 chassis in it, you've got the Harvard 400, which has the Alba CBM1 chassis, the CB40 chassis, which uses an MPSU31 output transistor and has a relay. Not the best, but not the worst. Squelch lets that down. You've got the Harvard 402 MPA, which uses the Cybernet Amstrad chassis. And then you've got the Harvard 404, which is the normal meter version of this. And then you've got this, and oh dear. So there's some really, really good sets, and then there's some quite poor ones. I'm just wondering if all this is supposed to be as it is. It's just not well made, and the board isn't cleaned off after manufacture. It's just as it's been soldered, to be honest. Now the sockets for the back of these were replacement ones were available by the company Workman, who are an American accessory company. I once tried to get an account with Workman, and you had to order 12,000 quid worth at a time, so I didn't order that on my 89 pence an hour pocket money. H403, yes, the Good Buddy. So these are popular sets and offered a lot of features for money. You've got the high-low power, which is part of 2781, which is good. Channel 9 switch for whatever reason, public address, RF gain, and this nifty vertical meter. So yeah, it certainly was popular. So I don't have any power leads for these. You can shove in a Cybernet 2-pin one, I think. I think you can. That you can pick them up. Last time I got any was from Knights at Curtin in Lindsay. So we'll power it up with the inevitable crocodile clips. Perhaps it's another one we ought to try and locate the mouldings for, like we did with the Maxcom ones, and like we've half done with the Amstrad ones. We're just waiting for the pins to arrive in June. So, just for my own silliness, I'll just put a plus on the left hand side, because otherwise I might end up doing it wrongly. So it's lit up and it says channel 19, so there we go. We'll plug it into the instrument speaker. It's making a hiss, but of course a subdued hiss with it not having the mic plugged in. I can't see any capacitors about to fail. And there we are into the test set. So I'll rewire the mic that I rewired, and we'll take it from there. Right, so we're back on. We've got the mic wired as it should be. We've got proper receive volume, and we'll switch picture in picture on, and let's see if we've got some transmit. We've got 3.5 watts. Let's see if we've got some audio. Wallow. Oh, well, let's have a look. Wallow. We've got 5 kilohertz deviation, so it can transmit on several channels at once. So what I could do with is the circuit diagram. The circuit diagram that I thought I'd brought in here. Obviously not. Right, and I've done these before, but I've gone through all the circuit diagram with some kind of attempt to work out what's what. There's a lot of adjustments in these. So we'll start with transmit. Now I don't have any specific VCO methods, but I'm sure if we got one in which was a snag, it would be quite easy to look at what's done on a set like a Cybernet 134, which uses the same phase lock loop, and to transpose that into this. But I don't need to do that, so we're going to put it on frequency. So we'll put the frequency counter up on the inset picture, key up, and let's see what we've got. It should be 2779125, so it's so off frequency that it wouldn't be working properly. Well, it looks like it's going to go. There we go. As done. 2779125 toggling 6. Ideal. So that's going to be VCO, so we'll leave that well alone. So what have I got for transmit? Looks like the trouble is, can we see what the coils are called? I've got some notes here, but whether or not you can read the coils is another matter. So I can see that's T13. I can see that's T2. Well, that's not one of the transmit ones. That's obviously VCO. T1. Oh, I don't know. That could be the first transmit one, so we'll go for that. I've got T1 on my notes. That is going to be VCO. So will we assume that this is our T2? Yes. So looks like we're going up this way. Yep. That's difficult to get to. See if that says anything I can read. T10 is receive. T9 is receive. So we're now on to T6 and L3 and T8. No, it's not L3. It's T7. T6, T7, T8. So I really need my green tool for that. It's peaked. It's peaked. Let's go through those again. So we've got about 3.6 watts there, which is fine. I'm at 13.8 volts. Out of interest, let's see what voltage we get 4 watts. So I'll key up. Oh, it's gone out of, the power supply's gone out of. There we go, 14. I'm not going to take it higher than 14.4, and we're about 3.9 watts at 14.4, so pop that back down. Obviously I've been in transmits for a couple of minutes and you start to have power dropping off. We'll come back to that when it's cooled down. Let's see what the meter's reading. it's banging across, so we really want that to be reading on the line of the 4. So I think, if I remember rightly, transmit meter from my notes is VR2. So we can find VR2, which is there. I don't want to put it in on its back because it's going to end up unplugging itself from the crocodile clips. The preset's actually dirty. Just got to where it wanted to be and it went to nothing. I want it bang on that line there, so we are with that. So on low power, let's see what it's doing. So it should be 400 milliwatts. It's 440 milliwatts. So that's jolly good. I think it's VR6. That's 5. There's 6. Let's see whether that's it. Nope. Just check I haven't affected normal power. We're now at 3.8 watts when I've gone from cool. That's if it has a preset for low power. So there's the switch. Let's see if it's this one. It's a, you know, the photocopy of a photocopy. It could be 5, it could be 6, and it could not be there at all. So it does look like it's got one. Well, that's something to come back to. Let's look at deviation. I think it's VR5 deviation, which we've now messed with. Let's get the oscillator out. Testing 1, 2, wallow, 1, 2. One, two, 1, 2, 1, 2. One, two, 1, 2, wallow, 1, 2, 1, 2. So deviation is VR1. So VR1 is that one, power meter is that one. That's what we've verified so far. Wallow, 1 2 1 2 1 2. One, two, 1 2, wallow. Just check these haven't been linked out underneath. Well, that certainly hasn't. And that hasn't. It's just giving me that kind of impression that it was not all as it seemed. I'm gonna have to compare with another set because this just doesn't look right, this wiring. It's too badly done. Anyway, for now, that'll do. Let's go over to receive. So make sure the RF gain's up. We're still on channel 20. And I can't hear anything. It's as deaf as a post. So I'll put the cyanide meter on. And let's see how deaf it is. Oh, not as bad as I thought. It's not bad at all, actually. It's actually 0.65 microvolts. It's because the RF gain was down a bit. So go through the front end. I'll tell you what, we'll put the oscilloscope on first with an S9 signal. Turn the bench light off. So we think T16 is the detector. And that looks like it's that one under that wiring harness. Spot on where it was. Always best to check though. Doesn't like this bench light, this radio. So over to the cyanide meter. Let's drop the squelch. We'll drop it to about 6 decibels. Little tiny bit gain there. Nothing gain there. We'll go over to the IF ones. Put a bit more signal on. Bit of an improvement there. Back the signal off a fraction, check that one. That's jammed. Managed to move that one. Let's try this one again. I think I've moved it a little bit, and it's about right where it is. So that's it. Oh, there's two more under here. That's an improvement. Back the signal off a bit. And the other one, go back to that one. Yeah, I think we're there. There's a front end of those, it looks like the IFs of these. Now that looks like another preset, which looks like it's been changed. I wonder if that's the low power one we were looking for. Let's turn the volume down, we'll go back into transmit. Yeah, it is. So the one at the front is low power. It's just lower than capacitor 65. I can't tell you which number. So that's I didn't spot that because it had been changed. So that leaves us with 3 presets. I'm not sure why we'd have 3 presets. Have we got a mic gain? I don't know. So we'll put an S9 signal on. And let's see what the meter reads. It should be S9. And it's about it's nearly S9, that. So it's going to be, we think, variable resistor 3, and VR3 is that one there. Yep, it is. We've got that bang on the middle of 9. So let's see what the sensitivity is now. What, about 0.65 was it? Funny if it was worse. It's 0.5, so that's excellent. And for 10 dB, it's 0.4, and for 20 dB, incredibly, it's 0.95 of microvolt. So it works very well. It doesn't mean it isn't a bleed over box though. So that brings us to Squelch. So I'm going to turn the Squelch to full. We'll set the signal generator for 100 microvolts. Let's go on to the attenuator. So 1, 3, 10, 30, 100. And we need to find the preset. So we'll think about this. Does it use an IF chip? No, it does not. So VR6 looks to be Squelch preset, which is there. Yep. There we are, that's set. VR6 is Squelch. So that must be VR4, must be low power. Because the only one we haven't sussed is VR5. which is there. It looks like power. Let's go back to high power. No, we'll leave it at midway position. We're a bit bamboozled on that. So Squelch, let's see what the sensitivity is like. So we'll turn the signal generator to standby at 0.3 of a microvolt. We'll set the Squelch to threshold. See when the signal generator comes in. Well, that's not very good. 3 microvolts to come in, 2.7 to come out. Let's just try that again, and I'll be more careful how I set the threshold. So really carefully set it this time. So 1.6 microvolts to come in, 1.5 microvolts to go out. That's a bit more like it. But it's not going to work like a lot of sets because it doesn't use the same receiver arrangement that most sets of this era do. So that's where we are. So let's just quickly flick on to transmit and let's see what it's doing. Now it's going to have cooled down to some extent. It was doing 3.8 watts. So as you start rabbiting, it'll drop down to 3.6. But it will do 4 watts on a 14.4 volt charge if it's cold, without fiddling about with any resistor values. And so they're not the most reliable set in the world, so they're not really something you want to be fiddling with. I think whilst they're working, they're best left alone. So I'm actually quite pleased with the result on that. So we'll pop the speaker back on. What I can't do is flick around the channels, so I will probably do that we'll probably finish the video when we've put the aerial together. So I'll just find where I've put the lid. Okay, so I've just been working on this aerial. I've put it up and cut 2 inches off. They say in the instructions, if you're using it on CB, you don't need to cut it, you can use adjustment rings. But I've not used adjustment rings because when they say using it on CB, it's a company which is Canadian. So they're expecting you to use it on the FCC set of channels, which of course are similar to the CPT set of channels. But we're not using it on the CPT set of channels, we're using it on the UK set of channels. So our centre of activity is going to be 20 plus. So our absolute peak SWR is 27.62. So it's actually absolute optimum is about channel 3 UK. So that means that we've still got a good SWR as we go into CPT. So let's go for channel 20 CPT. We've got what? 1.5. So as we go up the channels on CPT, and we start with UK, 7.9 is UK channel. So our SWR on channel 19 UK is 1.3, and as we come up to channel 31, which is what we use, we're coming up to 1.4, 1.5. So that was the answer to cut a couple of inches off. What this also means is we no longer have an SWR of 1.7, so that Murphy, will see how it performs with an SWR that's a bit better. I did cut the top 6 inches of cable off and re-soldered the plug on having cleaned the plug up. Everything was absolutely fine, there's no water in the cable. So now we will get on, if I can manage not to disconnect the power. One niner Roger. No, nothing on. That's not unusual, is it? So we'll do an on-the-air test later, and behind the scenes I'll test that Murphy again, and I'll let you know in the next video whether it actually stopped it humming a bit or whether it was a wild goose chase. But I've done the right thing. We've done the SWR, and it's probably a little bit better than it was before on the other aerial. So hopefully that will last another 7 years plus, and I'll put this radio back together. And there we are to conclude. It's all back in its case and it looks reasonably smart, apart from some holes in the top which I really don't care an iota about. 19 Roger. No, they've had the chance, they didn't talk. Right, we'll do an on-the-air test later. Thanks for watching. The Harvard H403 Good Buddy from 1981.